So here are the notes for rational functions in standard form. So here we're going to start with the general equation of this. So that general equation looks like f of x, which is really y, is going to equal 1 over x. This is one of our parent functions in the beginning of the school year. And if we wanted to make a graph, right, because that's what it's asking us to do, is to make this rational graph. We know there are two branches in quadrants 1 and 3. Let's go ahead and create a table here. So we'll start with x and y. Let's go and start with -4, -2, -1, 0, 1, 2, and 4. All right, and then all we're going to do is just literally plug it into that equation. So over here, if I did like 1 over -4, you can put that as a decimal or leave it as a fraction. But I'll make it a fraction, decimal here, -0.25. If I did 1 over -2, you would get -0.5. And if you do 1 divided by -1, you get -1, and so on. Now right here, when we do 1 divided by 0, if you type that in your calculator, it's going to say undefined. And that right there is going to be our asymptote. Then 1 divided by 1 is 1. 1 divided by 2 is 0.5 or 1/2. And then we get 0.25 when we divide by 4. All right, so if you take these points and you plot them on this graph over here, so -4, 1, 2, 3, 4, and -0.25, so somewhere like right there. -2 and -0.5, -1, -1. Let's see here. Boop. -2, -0.5, -1, -1. And then it's undefined. Undefined means it's an asymptote. So we have this right here, dash line I'm drawing right here for you. And then on the other side, we have 1, 1, 2.5, and 4.25. All right, now for this one here, just as a reminder, we do have two asymptotes. The first one is the vertical line at x equals 0. The second one is the horizontal line at y equals 0. So we have these two asymptotes that are the x and y axis. And then we're going to connect our dots. And when we make our dots for this rational function, we want to get them close to the asymptotes without crossing or touching it. So we're going to go ahead and graph this here. Notice I connected the dots. Get very close to the asymptote without crossing or touching it. And again, over here as well, just graph it really close. And again, you'll notice my branches are in quadrants 1 and 3, and there's a table I used to make it. All right, it says what type of graph is this? Well, this kind of graph is called a hyperbola. The domain here, I'll do this in Set Builder because that's one of the easier ones to do. So if you notice from left to right, it looks like it's all real numbers, but the only exception is this asymptote right there. So braces x such that x cannot equal to 0. So that means all real numbers except for x is 0. So the range is going to be very similar. Braces y such that y cannot equal to 0 as well. So that is your domain and range. So it's just those, it cannot equal the x-axis or the y-axis. So it cannot equal x is 0 and cannot equal y is 0. Now our vertical asymptote, again, that's that red dashed line that's going vertical. The equation for that vertical asymptote is x equals 0. And the equation for the horizontal asymptote, the red line going horizontal, is y equals 0. Those are the attributes of the rational function. Let's go ahead and continue moving on. All right, so now we're going to look at the standard form of a rational function. So the standard form of a rational function is this equation here. F of x equals a divided by x minus h plus k. And hopefully recall, if you remember this is our transformations, right? So h is our horizontal transformation. And if you remember the phrase, insiders lie. Okay, so remember, h is right here. Now, if you wanted to add parentheses right here to remind you that it's inside, you can do that. But just remember, for horizontal, insiders lie. So after you fix the lie, then it's true. So once you fix the lie, if the number is positive, it goes to the right. If the number is negative, it goes to the left. All right, k value, if you recall the k value, notice it's over here. That plus the k makes it positive k. It's your vertical transformation. Sorry, let's start there. So k is your vertical shifts. And if k is positive, it goes up. And if k is negative, it goes down. All right. If a is negative, the function is reflected across the x-axis. And so if a is negative, the number on top, notice where it's at, it's on top of the fraction. If that number is negative, then it reflects across the x-axis. So after you do the reflection across the x-axis, if one exists, then you do the absolute value of a, which means it's positive. If that value is greater than 1, then it represents a vertical stretch by a. And if the absolute value of a is less than 1 or greater than 0, that's going to be a vertical compression. And this is just review. We've already dealt with these transformations before. We're just kind of reminding ourselves of them. All right, and then now we're going to take a look here. So your vertical asymptote actually comes from the bottom right here. So insiders lie, so x is equal to h. And for your horizontal asymptote, it's the outside right here, y equals k. So those are your vertical and horizontal asymptotes. All right, for these examples, it says, identify the transformations applied to the parent and then state the asymptotes. Yes, that's it. Okay, so right here. And another way about the vertical asymptote, I was just looking at it, if you wanted to set it equal to 0, you could. And when you add the h, you get x is equal to h. So that's kind of how you can do that as well. All right, so right here, let's look at this first one here. First, we're going to do our transformation table like we always do. So we have x and we have y. So in terms of our horizontal transformations, we're looking right here at x, and there's nothing happening there. So we're going to leave the x column blank. But right here, this -2, that is a vertical transformation. That means down 2, so it's affecting the y values by down 2. All right, so now it wants us to state the vertical asymptote and the horizontal asymptote. Okay, so for the vertical asymptote, we had no shift that was going left or right. So that means our vertical asymptote stays at x is equal to 0. For a horizontal asymptote, we know originally it's supposed to be y equals 0, but here it went down 2 units, so y is equal to -2. All right, for our next problem, 1 over x plus 3. So we do see that we have an h, but we don't have a k. So for our transformations here, x, insiders lie, that's really a -3. So -3 is going to be left 3. But there is no k value because it's not moving up or down. So in terms of my vertical asymptote and horizontal asymptote, so for my vertical asymptote, this time we move left 3, so x is equal to -3. And for my horizontal asymptote, it didn't move up or down, so y stays at 0, so y is equal to 0. All right, and for the last one here, there looks like there's 3 transformations happening there. So we'll go with the horizontal first. We see x minus 5. And again, you could all set that equal to 0 and solve it. So insiders lie is really a positive 5, which means it goes to the right 5 units. And then for your y values, the first thing I see is this negative sign right here. So the a value is negative. That means it reflects across the x-axis. And this positive 3 right here means your graph goes up 3. All right, so in terms of our horizontal and vertical asymptotes, so for our vertical asymptote, it goes right 5, so that means that x is equal to 5. For our horizontal asymptote, reflection across the x-axis does not actually affect the horizontal asymptote at all. But we did go up 3, so now y is going to equal 3. All right, let's take a look at the next set of problems here. The rational parent function is reflected across the x-axis, then translated 4 units right, and 3 units down. Write an equation to represent the new function. Identify the asymptotes. Okay, so here, let's talk about the parent function equation, or the standard form here. So y equals a divided by x minus h plus k. All right, then we'll make our xy table so we can kind of remember what it looks like, what the transformations are. So first we have reflected across the x-axis. That's a vertical transformation. Translate 4 units to the right. That's right 4. And 3 units down. So on the y, that's down 3. Okay, so now we're going to apply these transformations to the graph, or to the equation. So first off, we don't have any vertical stretch or vertical compression. So a is going to stay 1. But the reflection across the x-axis makes the a value negative. So that 1 becomes negative 1. We have right 4. When we plug it into the function right here for h, insiders lie, so it becomes x minus 4. And then last, the down 3 plugs in for k. That's down 3, so that's going to be minus 3. So our equation should be y equals negative 1 divided by x minus 4 minus 3. And then last, it said to identify the asymptotes. So for my vertical asymptote, we know it is right 4, so that's going to be x is equal to 4. And for the horizontal asymptote, it went down 3, so y equals negative 3. All right, let's go ahead and try this next one here. So this one says the rational parent function is vertically stretched by a factor of 2. Okay, so that means the a value is changed to 2. Then translated 7 units up, so k value is going plus 7. And 1 unit left, so that means h is going left 1, okay? So when I write this equation, so f of x equals, so my a value, it's a vertical stretch by a factor of a, by up 2, so that's 2 divided by, then it's translated 7 units up, that's k, and 1 unit left, that is h. So if it's x minus 1, insiders lie, so that's going to be x plus 1. And then translated 7 units up is, for k is plus 7. And identify the asymptote. So for your vertical asymptote, x plus 1, so it goes to the left 1, so x is equal to negative 1. For the horizontal asymptote, your k value is positive 7, so y is equal to 7. All right, let's continue on. It says directions, graph each function, identify the domain, range, and asymptotes. Okay. So over here, we're going to identify our asymptotes first, okay? So that's the first thing we're going to do. So transformation-wise, we know that this one goes, it does not go right or left anything. So if we set this equal to 0, we still get x equals 0. And for our k value, it's negative 2, so y equals negative 2. So I'm going to go ahead and graph these real quick. All right, so we have x is equal to 0 and y equals negative 2. Okay, so there are my 2 branches. Now, to make this table, let me kind of show you what you're going to do. You're going to identify your vertical asymptote, which is right here. Okay, you're going to create a table. And on that table, you're only going to pick 2 x values. You're going to pick one x value to the right of that vertical asymptote. So if it's at x equals 0, one number to the right would be 1. And they're going to pick one number to the left of that, which would be negative 1. And honestly, it can be any number that you want. I always pick 1 to the right and 1 to the left. So one number to the left of 0 is negative 1. One number to the right of 0 is positive 1. Okay? And now last, to figure out what these values are going to become, let me actually move this down a little bit, see if I can. What I'm actually going to do is I'm going to just plug these numbers in. So watch. If we plug in a -1, so we're going to plug it into this function here. So f of x, which is really y, equals 1 divided by -1 minus 2. 1 divided by -1 is -1, and -1 minus 2 is -3. So we actually have a point at -1 and -3. All right, now we're going to plug in the 1. So 1 divided by 1 minus 2. 1 divided by 1 is 1. 1 minus 2 is -1. So now I'm going to plot that point, 1, -1. And now, so let's talk about the branches. The branches can be in two quadrants. They can be in quadrants 1 and 3 or 2 and 4. Now, sometimes they go into another quadrant. If we get there, we'll talk about that. But right now, 1, 3, or 2 and 4. So all we used this for was so we could see where our branches actually are. So my quadrants for me kind of move with my asymptotes. So if you see the first dot, it's in the quadrant 1. So I just draw it coming from there, getting close to the branches, or getting close to the asymptotes. So this branch is in quadrant 1, and the other branch is in quadrant 3. Again, you start from that dot, you get close to the asymptote without crossing or touching it. And then from here, we can do the domain, and we could have honestly done the domain and range earlier, but we know that domain cannot equal the vertical asymptote. So braces x such that x cannot equal 0. And for the range, braces y such that y cannot equal -2. And we have all the information that it asks us for now. All right, let's take a look at this next one here. So again, we're looking at transformations. The only transformation I see here is left 3. So here we're going to say x is equal to -3. And for our k value, there is no number, so y is equal to 0. And here, again, you could literally do the domain, but I like to do the graph because that way so we get the habit of seeing the graph before we actually take the domain. But again, right here, we know it can't be the vertical asymptote, so you can easily put x cannot equal -3 and y cannot equal 0. But just to verify, let's first start by creating our table. Okay, so we know we have a vertical asymptote at x is equal to -3, so 1, 2, 3. And our horizontal asymptote at y is equal to 0. All right. So now we're going to go over here to the equation. Or our graph, we're going to look at our graph where asymptote is at -3. So we're going to pick one number to the left, which I would pick -4. And then we're going to pick one number to the right of that vertical asymptote, -3, which would be -2. Now, if you want to pick 0, 1, or whatever you can, I just pick these because they're to the left and right. Okay. Now for the first one, I'm going to plug it in, -4. So f of x equals 1 over -4 plus 3, which is -1. Because -4 plus 3 is -1. 1 divided by -1 is -1. And for the second one, I'm going to plug in -2 now. So 1 over -2 plus 3. So -2 plus 3 is 1. 1 divided by 1 is 1. Okay, so we're going to plot these points now and see which quadrant our branch is in. So we have -4, -1, and we have -2, +1. And again, our branches are going to be in quadrants 1 and 3. And there you go. So for our domain, we can see that it's all real numbers except x cannot equal -1, -2, -3. And for our range, y such that y cannot equal, and this one was just 0. All right, and there's all the information we need for that one. All right, let's go and move on to the next examples. All right, so this one has -4 over x plus 1. Okay. So for this one here, again, we'll do our vertical asymptotes and such. So the first one here, right here, x has nothing, so that's x is equal to 0. We said equal to 0, there's nothing there. And for the other one, the k value, y equals k, that's plus 1, so y is equal to positive 1. So let's go ahead and graph these. So x equals 0 is right here. And y equals 1 is going to be 1 unit above the x-axis, right? So there is our asymptote so far. For our domain and range, we'll get those after we make the graph, but you could do that right now. So I'm going to go look at the vertical asymptote, which is at 0. So I'm going to pick a number to the left, which is -1, and one number to the right of 0, which is positive 1. Then we're going to plug that in to figure out our x and y values so we can plot our points. So over here we plug into the function f of x is equal to -4 over, first one is -1 plus 1. -4 divided by -1 is 4. 4 plus 1 is 5. So we have -1, 5. Oh, let me see. Let me verify this. Oh, I don't know why I put that. I put a -1 when it should have been -4. So let me fix that. It should be -1. -1 divided by -1 is 1. 1 plus 1 is 2. Sorry about that. Okay, hold on. Give me a sec here. I feel like I'm making a small error here. Okay. So it is -4 on top, which I did have. I'm plugging in -1. -4 divided by -1 is 4. 4 plus 1 is 5. Okay, so I had that right. I'm not sure why I changed that. All right. And now we're going to do the second one. So we have -4 on the top over x is 1 plus 1. -4 divided by 1 is 1. 1, -4 plus 1 is -3. All right, so let's go ahead and check these points here. So we have one at -1 and positive 5. 3, 4, 5. There's that one. And then we have one at 1 and -3. So 1 and 1, 2, 3. Okay. And there is our points. So we can see they're going to fall into quadrants 2 and quadrants 4. Okay, so there is our graph, and now we can do our domain and range. So braces x such that x is equal to 0. And for my range, braces y such that y cannot equal to 1. Let me fix that. And there we go. All right, we're now off to our next example. All right. So, one thing we could talk about over here are just transformations if you're curious. So this negative right here is a reflection across the x-axis. And you can kind of see that taking place because originally our branches are supposed to be in quadrants 1 and 3, and they reflected across the x-axis. So that's why they're now in quadrants 2 and 4. And then up 1 shows that our horizontal asymptote is now at y equals 1. Over here, our transformations for the next example are a vertical stretch by 2, which means our graph will get a little bit more narrow. Then we have x plus 4 on the bottom, so insiders lie, that goes left 4, and that's going to be h, so that we're going to say that x equals -4 for our vertical asymptote. And then for the next one, we have k is -7, that is down 7, so y is equal to -7. All right, we'll make this one here. 2, 3, 4, 5, 6, 7. All right, let's make our table. And again, like I said, as long as you pick numbers to the left and to the right. So for this one here, we'll do -5 because that's 1 unit to the left of -4. And then here, now for this one here, we can use whatever we want. I'll just go to the right one of it. So that'd be 1 to -3. So I pick 1 to the left of the vertical asymptote and 1 to the right. So let's go and plug them in. So f of x equals 2 over -5 plus 4 minus 7. So -5 plus 4 is -1. So 2 divided by -1 is -2, and -2 minus 7 is -9. So that's my first point. So -5, -9. And for my second one, we're going to plug in negative 3. So 2 over negative 3 plus 4. So negative 3 plus 4 is 1. 2 divided by 1 is 2. 2 minus 7 is negative 5. All right, let's go ahead and plot these points. So we have first one is at negative 5, negative 9. So negative 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. And my second one is at negative 3, negative 5. So negative 3, 1, 2, 3, 4, 5. And then we get close to the asymptotes without crossing with our branches. And again, you'll see it is in quadrants 2 and 4. There we go. And in terms of the domain, all real numbers, x such that x cannot equal to negative 4. Braces y such that y cannot equal to negative 7. And there's our domain and range with all the attributes I was asking for. All right, let's continue to move on. Or actually, that is it. All right, so that's going to complete the notes for this, for the graph and rational functions.